Okay, let's do number 9 on the back of the review sheet. It says a car moving on a level highway has a mass of 4.0 times 10 to the 2 kilograms. The coefficient of friction between the tires and the highway is equal to 0.19. What acceleration will a force of 2250 produce on the car? So this force here, this is like an applied force. It doesn't say a push or a pull, but that's my FA. So the first thing I want to do is I want to draw my free body diagram. So I need to establish my sign convention, and I'm going to say the car is moving this way to the right, because I'm going to use my standard Cartesian sign convention that I use in math class that says up and to the right is positive, because it makes it easier. So now I'm going to draw everything that's going on it. So what's causing the car to move forward? I mean, it's really like the thrust of the engine, but we'll just say this is FA. Friction acts in the opposite direction, parallel to the surfaces in contact. The force of weight acts down, and the normal force acts perpendicular to the surfaces in contact. They give me the mass, so right off, I'm going to try and find my weight. So F of G is equal to mg, so it's equal to 4.0 times 10 to the 2 kilograms times 9.8 meters per second squared. So F of G ends up coming out to be 3920 newtons. And remember, I want to find A. Now, because I know A is going in this direction, I know I should just probably do that last. Because obviously, if I do it first, I'm going to have too many unknowns. Because remember, on problems like this, we have 3 things to do. We sum forces horizontally, we sum forces vertically, and then we use the mu equation. Well, if I'm solving forces horizontally and I don't know this, I'm probably not going to know something else. So let's start with vertical. So summation of f of y is equal to ma. Is this block accelerating vertically? No, it's not even moving that way. So this is 0. And now underneath, I'm going to look and say, well, what do I have? I have Fn, which is positive, minus Fg, which is negative, and that's equal to 0. So Fn is equal to Fg, which is 3920. Now I'll use my mu equation. Mu is equal to f of f over f of n. I know mu. I don't know f of f, and I just found f of n. So f of f is equal to mu times f of n, so it's 0.19 times 3920. So f of f ends up being about 745. The last thing I can do is I can use now sum forces vertically. So I'm going to say summation of f of x is equal to ma. Is this accelerating? Yes, that's what I'm solving for, so this doesn't go to 0. I look at my free body diagram. Fa is positive, ff is negative, and that's equal to ma. Now the problem with some high school books is they just go, okay, magic, working equation. They don't show that you're summing forces and you're applying Newton's second law in that direction. Okay, they just pull it out of a hat. So since we want to solve for A, I'll rearrange the equation. Fa minus f of f over m is equal to A. So Fa is 2250 minus f of f, which is 745, that's newtons, over my mass, and that gives me A. So A comes out to be 3.8 meters per second squared. And that's it.